Welcome to the deep dive. Today, we're heading out way beyond our solar system.
Far out.
Yeah, into the cosmic wilderness, I guess you could say. We're exploring something really fascinating, rogue planets.
Mm-hmm.
You probably think every planet needs a star, right? But the sources we're looking at today, that's not always true.
Definitely not.
We're going to unpack what these cosmic nomads actually are, how they end up wandering alone, and maybe the biggest question, could they actually support life?
But a wild concept.
So, okay, picture a planet. You see it orbiting a star like Earth does, but these rogue planets, they just break that mold entirely. What are they exactly?
Well, it's fascinating because they really challenge our, standard picture of how things work out there. Rogue planets, people also call them interstellar planets or nomad planets. They're basically planetary mass objects,
Okay.
but they're just floating through space on their own. They're not gravitationally tied to a star, just drifting in that huge, dark emptiness between the stars.
Wow. Just adrift. So how does that even happen? How does a planet become a lonely wanderer? Sounds pretty dramatic.
It does, yeah. And there are basically two main ideas about how they form or how they end up this way.
Okay.
One theory is ejection. So imagine a really young solar system. Things are still messy, gravitationally speaking.
Right, chaotic.
Exactly. Planets are jostling around. A planet could get too close to something huge, like a Jupiter-sized gas giant, and basically get slingshotted right out of the system.
Kicked out.
Pretty much.
Back.
Just gone. The other idea is direct formation. They might actually form all by themselves out in the dark from collapsing clouds of gas and dust, kind of like stars do, but they just never get massive enough to, ignite fusion.
So they're like failed stars, almost, or just independent planets from the start.
It could be either, yeah. The
Yeah.
failed stars is one way to think about some of them, or maybe just objects that form below the mass needed for fusion.
Okay, that makes sense. But gosh, without a star, they must be incredibly desolate, right? Unbelievably cold, perpetually dark, no day, no night. How would we even find these things?
You've hit the nail on the head. They are extremely cold, possibly colder than Pluto, and yeah, pitch black.
Wow.
And that makes them incredibly hard to spot. They don't shine their own light, and there's no nearby star for them to reflect. So astronomers mostly rely on a couple of clever tricks.
Like what?
One is called gravitational microlensing. It sounds complicated, but the idea is if a rogue planet happens to drift exactly between us and a distant star,
Huh?
its gravity actually bends the light from that background star.
Yeah.
It acts like a lens, magnifying the star's light for just a brief moment.
Oh, okay, like a cosmic magnifying glass.
Exactly. It's a very fleeting signal, but it tells us something massive and dark passed by.
Mm-hmm.
The other method is using infrared telescopes to look for larger, younger ones that might still be glowing faintly with heat left over from their formation.
Right. Residual heat still sounds incredibly difficult.
It is very challenging work.
Yeah. Okay, but here's where my mind really starts to bend. Could anything actually live on one of these? A dark, frozen, isolated world. It just seems impossible.
Yeah, that's the really provocative question, isn't it? And surprisingly, the answer isn't a definite no. It's
Huh?
possibly yes, under very specific conditions, mind you.
Really? How? What conditions?
Well, the key wouldn't be sunlight, obviously. It would have to be internal heat. If a rogue planet is massive enough, its core could still be hot, generating geothermal energy.
Okay. Heat from the inside.
Right. And if it also has a really thick atmosphere, like hydrogen or helium, perhaps,
Mm.
that atmosphere could act like a super insulating blanket, trapping that internal heat.
Ah, like a greenhouse effect, but powered from within.
Sort of, yeah.
Yeah.
And even more intriguing, some might have liquid water oceans beneath thick icy shells. Think like Europa or Enceladus in our own solar system, but potentially on a planetary scale.
Subsurface oceans, kept liquid by the planet's own heat.
Exactly. And if you have liquid water and an energy source, in this case geothermal energy, perhaps driving chemical reactions like we see deep sea vents on Earth.
Then you don't need sunlight at all.
Precisely. Life could potentially arise and thrive in those dark hidden oceans, completely independent of a star.
That just, wow, completely changes the picture of where life could be. So zooming out, what does the existence of potentially billions of these things mean for, the big picture, our understanding of the universe?
It's hugely significant. First, rogue planets could be incredibly common. Some estimates suggest they might actually outnumber stars in our galaxy, maybe even by a lot.
Outnumber stars.
Yeah, potentially 10 or 20 times more rogue planets than stars, which, if true, tells us a lot about how planetary systems form and how maybe chaotic and messy that process often is.
Right, suggesting ejection is pretty common.
Could be. or that formation and isolation is efficient. But beyond just planet formation, it radically expands the definition of a potentially habitable environment. It pushes us way beyond that traditional habitable zone concept, the Goldilocks zone around a star.
Life could be lurking in places we never even considered looking.
Exactly. It means the potential niches for life in the universe could be vastly more numerous and diverse than we ever imagined.
So, just to recap our deep dive today, we've explored these incredible rogue planets, these lonely travelers drifting through interstellar space.
Hmm.
They're cold, they're dark, incredibly hard to even find, and yet
And yet they might harbor hidden oceans, warmed from within.
potentially teeming with unique forms of life that have never seen a sun.
It's a mind-bending possibility.
It really is. So, here's something to think about. If life can find a way in the crushing depths of Earth's oceans, totally without sunlight, and maybe, just maybe, on these starless worlds wandering the galaxy, well, what other completely unexpected places could life be thriving? Maybe the universe is far more full of life in far stranger places than we currently dare to think. Perhaps the most vibrant spots aren't the bright ones, but the hidden ones.